Hello everyone, great to see you in this video of kinematics and dynamics of machinery. In this video, we will be talking about gyroscope, presented by Group 8 from Class 3. Group 8 consists of 5 people. First is Juan Aron Norata, second is Eva Nathanael, and third is Muhammad Rizky Amiruddin, fourth is Nicholas Patrick, and the fifth, the last, is me, Nico Andreas. In this video, we will be going through what a gyroscope is and how it works and its applications. First, what is a gyroscope? A gyroscope is essentially a spinning wheel, or it can be a disc too, in which the axis of rotation is free to assume any orientation by itself. It is also a very useful device for measuring or maintaining orientation and angular velocity. We'll look at this first video. First, the gyroscope is spun and put on a support. It goes through a phenomena called precession, and while doing that, it maintains its orientation. For the second video, you can see when the gyroscope is spinning, even when the plane is tilted, it still maintains its orientation.
Okay, on to how does it work? A gyroscope works by using the precession phenomenon to generate torque. Precession is the phenomenon at which an object spins perpendicularly to its spin axis. As such, it can generate torque due to moment factors multiplying onto each other, resulting in another moment couple that we can use. As seen in this diagram, if a spin axis spins the object around the, let's say, y-axis, and then it precesses over the z-axis, then it will have a torque going to the x-axis, at which it will spin around in that area. For example, in this video, we can see that an object spins around over this axis, at which we can say this x-axis, and then it has a weight that goes onto this axis. Let's say it's a z-axis. So an object that has an x-axis and a z-axis spinning will generate a torque on the y-axis. As seen in this video, the bicycle wheel will spin. Why does this happen? This happens, for example, in this video, in the satellite, we can see that satellite goes around the Earth by rotating. Let's see. And let's say we give a moment in this area as shown in the video. We can see that the trail will not just randomly go up and down that way. It will go up following the track smoothly. So it follows the track in this video. As such, we can see that if an object spins around, let's say, the y-axis, and then the x-axis, we give a torque, we give a moment at which it precesses, it will generate a torque in this axis. Let's say x, and then y, it will give a moment in z. Now, why does this happen? Now, how can we use this? We can use this in as example, small boats, at which we need it to roll in this way or that way, let's say. Now, we can have an object that spins, at which a gyroscope spins in that way, and then we can precess it by using controlled pneumatics. As such, it will generate a torque that rolls the boat. Okay, now we go on to the math. Basically, as seen before, an object has an angular speed of, let's say, omega s, and then it precesses with a speed of omega p because of a torque p. Now, how do we know how much torque is generated by the omega s and omega p, with omega s being omega angular speed of the spin and omega p being the angular speed of the precession? We can use this diagram as seen in the PPT, at which we know that torque is the rate of change of angular momentum. And then we can know that the angular change of the angular momentum is shown as T equals to 2 e omega spin per delta T sin delta V per 2. As such, if we find the limit at delta T equals to 0, we can get that delta V is equal to 0. Therefore, sin delta V per 2 equals to delta V per 2. So we can generate the formula as T equals to E omega spin delta V per delta T. As such, T equals to E omega spin times omega precession.
Hello, everyone. So we have already learned about what a gyroscope is and how it is supposed to operate, how its behavior is. But there is a question, which is, what is the application of a gyroscope? What can we do with it? So in this session, I'm going to explain briefly about what are the applications that a gyroscope is usually used for. So why is a gyroscope used in the first place? The gyroscope has two properties that is quite essential for many components in many different fields. First, gyroscopes have two properties that are used in flight instruments, which is rigidity in space and precession. Rigidity in space property states that a gyro will stay in place along the axis it spins, resisting any force that tries to displace it. Precession is a property stated that if a force is applied to a gyro perpendicular to the axis of rotation, it will manifest itself in a 90 degrees further along the axis of rotation. So, one of the main uses of gyroscopes is satellites. In satellites and spacecrafts in general, there is a need to control where your satellite or spacecraft is pointing. In order to achieve this, there's a system called an attitude control device. The most prevalently used principle for these kinds of purposes is gyroscopes in the form of control moment gyros. So, control moment gyros are gyroscopes that help control where a satellite is pointing. In space telescopes, meanwhile, a gyroscope can be used to stabilize its attitude owing to a gyroscope's ability to increase the torque or disturbance needed to change the direction of a gyroscope, similar to a spinning bullet in principle. You can see here that you can see the control moment gyros and here you can see how it looks like. This is a spacecraft, a satellite, and you see the attitude is basically the coordinate system to demonstrate where it is pointing. And here you can see the essential principles of how it moves. Control moment gyro is spinning in the form of a wheel. Its angular momentum, let's say, is pointing towards us, as shown in the red arrow. And then the torque applied from the spacecraft is to the right of us, as you can see in the blue arrow, the torque from the spacecraft. So what happens when you apply torque from the spacecraft? It creates a resultant torque in the direction from the angular momentum towards the torque of the spacecraft, in which the exact values of this torque can calculate it using the formula that we derived before. You can see the application of this from this simulation. As you can see, we have a satellite, for example, and then using this satellite, we need to point it to Earth, for example. So how do we do that? Well, we use control moment gyros from this module. There's a control moment gyros in here, so that when we want to turn the spacecraft, we use the principle as shown before in order to move the spacecraft like this. You can move it up, down, left, right, and the roll axis. So by using the principles of a control moment gyros, you can control where a satellite is pointing. That is the first application of a gyroscope.
Next, I'm gonna explain about a gyroscope application on an airplane. First, what it is called gyroscopic flight instrument. Gyroscopic flight instruments are instruments which have a mechanical gyroscope incorporated into their design. Gyroscopic flight instruments are used in most general aviation and in other commercial aircraft. For example, altitude indicators, turn coordinators, and directional gyro. The gyroscope within the instrument are usually electrical or vacuum driven. and make use of the basic gyroscopic principle to display the position of the aircraft. In more modern installations, mechanical gyroscopes have been replaced by laser gyros. Next, the vacuum gyro functions wherever the engine is running and generating sufficient power to create enough suction to spin the gyro. It powers the altitude indicator. As its name implies, the altitude indicator substitutes for the pilot's view of the horizon during pure visibility. This flight instrument exploits gyro properties of rigidity in space. Next instrument is turn indicator. Turn indicator works by exploiting precession. As the aircraft turns, a force is applied to the gyro, which translates to a perpendicular force applied on the gimbal. Next is the heading indicator, or the directional gyro indicator, which displays the aircraft direction. The directional gyro exploits the principle of rigidity in space. As the aircraft rotates around, the gimbal drives a gearing system that turns the compass card. Precession will cause the instrument to become steadily more inaccurate, so it needs to be recalibrated against a magnetic compass.
Next, I will explain gyroscopes' application on sea crafts, such as boats and ships. Gyroscopes are used in sea crafts as a stabilization instrument. It is used to stabilize roll motion in ocean-going ships. The stabilizer typically operates by constraining the gyroscope's roll axis, allowing it to precess either in the pitch or the yaw axis. Allowing it to precess as the ship rolls causes its spinning rotor to generate a counteracting roll, stabilizing moment to that generated by the waves on the ship's hull. Here on the right is a diagram of how gyro stabilizer on ships and boats works. Here there's the yellow arrow, which is the tau precession. It is the torque caused by the spinning rotor. Because of the precession, it causes the green arrow, the tau gyro, which is the counteracting roll. The counteracting roll it used to stabilize the moment that is generated by the waves, which is the blue arrow, the tau wave. That's all from me.
That's all for this video. Thank you and see you again.